Okay, hello everyone. Welcome to our 15th class of computer architecture and organization. So, in the last class, we have discussed about this concept now. So, in the last class, we have discussed about the concept called memory location. Okay, so what is meant by memory? Where we used to store the data or instructions or program, whatever it may be. Where we will store the program or data or set of instructions or intermediate values, it will be referred as memory. Okay, so we have discussed about the memory concept in the last class. Okay, in this class we are going to discuss about the next concept called addressing. What is meant by addressing? See, the addressing concept that is present here is similar to the addressing concept of our home. Okay, so I think you all are very much familiar about our door number. Okay, so whenever if anybody asks our address, we used to say start our address with the door number, street number with so and so line and so cross street. Okay, fourth line, sixth cross street, like that with so and so street name, and we will tell the entire details, isn't it or not? Our door number is so and so. It is present on 4 by 6th or 5th 5 by 4. So fifth line, fourth cross road of so and so street. Okay, it is located in so and so Guntur, Andhra Pradesh, India. Like that we used to write the address. Here also the same concept. Okay, what is the main purpose of having an address for each and every individual? What is the purpose? Means it is easy to identify where we are present. It is address is nothing but an identification. That means whenever if somebody needs us, it is easy to locate where we are placed. Okay, so here also for every memory location there is an address. What is the purpose of the address? Is storing of a data and retrieving of the data will become easy when we are having address, isn't it or not? For example, if anybody sends us any money order or whatever some information, if we have address, that means if you want if you book any item in an online, then it will reach you correctly when you give the correct address, isn't it or not? So as you are having some door number, street number, and what you will call a street name and city name and all these things, pin code and all these things, it is possible for that particular courier person to give you the required courier. If not, it is not possible, no, because if I write only Mohan Krishna Guntur, it may not be possible for the courier person to give me the courier, because there may be n number of n number of persons with the same name, isn't it or not? Okay, similarly here also the addressing means for every memory location there is an address, just like for every house there is a house number. Okay, it will make the identification very easy. Okay, so that is the concept of this address. And what the what you call the writer is going to specify is, if for example we are having k number of bits, if this concept is similar to the concept in our STLD. If I have k number of bits, I can access 2 power k number of locations. That means if I have 4 bits, I can have 16 distinct addresses starting from 00000 to 1111. Isn't it or not? Yeah. And wait. See, if I have 4 addresses, if I have 4 bits, okay, that means, okay, the bits are A, B. If I have 4 bits by named A, B, C, D, okay, so then by using these 4 bits, I can develop 16 different combinations, isn't it or not? Starting from 0000, 0001, 0010, 0011, 0100, and so on up to 1111. So these things you are very much familiar in your STLD, switching theory and logic design, isn't it or not? So here what is the main thing is, if you have n number of bits, you can have 2 power n number of possible memory locations. That's what he wants to deliver the message. If you have k bits, we can access 2 power k memory locations. Okay, na? And the memory location always starts from 0. Okay, that means take this as an example. I have k is equal to 4. That means I have 4 bits. So then how many memory locations I can access means 2 power 4. 2 power 4 means 16 memory locations I can access. Okay, but the number of the starting memory location should be start from 0. The memory location of the starting instruction should be should start with 0. That means though I can access, if for example I have 4 bits means I have 16 distant addresses, the starting address should start with 0. That means the ending address should be 15, isn't it or not? Okay, that's what he has specified in the next this point. The address ranges from 0 to 2 power k minus 1. Though you have 2 power k memory locations, but the first memory will always starts from, the first memory location will always starts from a 0. Okay, so the ending memory location will not be 2 power k, but it will be 2 power k minus 1. 2 power k minus 1. That means I have 16. If there are 16 possible combinations, it will start from 0 to 16 minus 1. That means 0 to 15. Okay. If I have 5 bits, then 2 power 5 possible combinations are present. 2 power 5 means 32. That means it will start from 0 to 32 minus 1. That means 0 to 31. Okay. So that's what he wants to specify here. Next, along with this concept, he is mentioning some values. These are the standard values one should remember. Okay, what is the value of 1 KB? And one more example he has given. See, if I have 24 bits, how many memory locations I can access is 2 power 24. How much? 2 power 24. See, 2 power 20 means it is 1 MB. 2 power 10 means it's 1 KB. 2 power 20 is nothing but 1 MB. And we are having 2 power 4 as a 2 power 24 can be written as 2 power 20 into 2 power 4. 2 power 20 means 1 MB into 2 power 4. 2 power 4 is nothing but 16. So 16 into 1 MB. The total value is 16 MB. The total value is 16 MB. Okay. That means if I have 24 bit addresses, then the total value is 64 MB. So how it came means, see, 2 power, where it is, 2 power 24. 2 power 24 can be split as 2 power 20 into 2 power 4. Okay, so if you observe here, 2 power 20 is nothing but the equivalent value of this 2 power 20 is there na? So the equivalent value of this 2 power 20 is nothing but 1 MB. 1 MB. So 2 power 20 is nothing but 1 MB stands for megabyte. Okay, into 2 power 4 means 16. Okay, so 16 into 1 MB is nothing but the total value is going to become 16 MB. 16 MB. So this is the concept. Okay, 2 power 24 can be split as 2 power 20 into 2 power 4. Okay, the value of 2 power 20 is nothing but 1 MB into 2 power 4 is nothing but 16. So 16 into 1 MB, the total value is 16 MB. Okay, if I have 24 bits, then a total of 16 MB memory is going to be generated. And here he has specified what is meant by KB, what is meant by MB, what is meant by GB, and what is meant by 1 terabyte. 1 MB stands for 1 KB stands for 1 kilobyte. First of all, what is meant by byte? Group of 8 bits is called byte. See, 1 byte, 1 byte byte is equal to how much means 8 bits. 1 byte is nothing but 8 bits. Okay, so group of 8 bits is called byte. First of all, what is a bit? Single bit binary data storage device. That means bit consists of either 0 or 1. Okay, group of 8 bits is called 1 byte. 1 kilobyte. Kilo means here, as far as mathematical concept of view, it is 1000. Kilo means 1000. Kilogram means 1000 grams. But as far as computer point of view or memory point of view, 1 kilo means it's not 1000, it is 1024. 1 kilo. 1 kilo means it's not 1000, it is 1024 bytes. 1024 bytes. Okay, na? Is it clear? So 1 kilo is not 1000 here, and it's 1 kilo is not just here. The concept is not like the concept that is present in weighing. Okay, as far as weights, that means whenever you buy a vegetables or whenever you buy some sugar like that, there 1 kilo is nothing but 1000 grams. But as far as computer and memory point of view, 1 kilo is not 1000, it is 1024. Okay na? So similarly, so 1 kilobyte means it's nothing but 1024 bytes. 1024 bytes. Okay. Next, similarly, 1 MB, 1000 kilobytes is called 1 MB. 1000 KB is called 1 MB. Here what they have given is see here what he has mentioned 1024 kilobytes. What does it means? Means 1 MB is nothing but I have written 2 power 20. 2 power 20 is nothing but 2 power 10 into 2 power 10. Okay, 2 power 10 is nothing but 1024. So 1024 kilobytes is called 1 megabyte. Similarly, mega means 10 power 6 amma. Giga means 10 power 9. So 1024 megabytes is called 1 gigabyte. Similarly, 1024 gigabytes is called 1 terabyte. Is called 1 terabyte. So we have 1 kilobyte, megabyte, gigabyte, terabyte. Okay na? 1 kilobyte is nothing but 1024 bytes. Okay. 1 megabyte is nothing but 1024 kilobytes. 1 gigabyte is nothing but 1024 megabytes. 1 terabyte is nothing but 1024 gigabytes. This is the concept you have to remember, because this concept you have to you have to memorize very well, because everywhere whenever you go or whenever you come across any computer terms, that means either MPMC or microcontrollers, whatever it may be, you will get these terms very frequently. 1 MB, 1 GB, 1 TB, like that. Okay, I think you are all very much familiar now. You might have pen drives with 4 GB, 8 GB, 10 GB, like that. Okay, you might have hard disk with 500 GB or 1 TB, like that. What does 1 terabyte means? 1 terabyte is nothing but 1024 gigabytes. That is its storage capability. 4 GB pen drive means it can store 4 GB of data. 4 GB is nothing but 4 into 1024 megabytes. Okay, like that this memory concept will exist. Okay, so this is the concept of addressing. Now we are moving into the next slide. Yeah, memory addressability. See, how can we address a memory? Okay, there are 3 different types of addressing a memory. One is, that means different instructions has different types of memory addressability. Generally, there are 3 basic information qualities to be dealt with. Okay, there are 3 types of memory addressable techniques. One is bit addressable, second one is byte addressable, third one is word addressable. There are 3 different types of memory addressable techniques. First one is bit addressable, second one is byte addressable, third one is word addressable. What is the difference between these things? Okay, see, if for example in the previous class itself, whenever we have discussed the concept of words, we have discussed that it is there will be some what do you call some values. They are always preferred to be stored in a bunch. They cannot be separated from each other. They used to store in the consecutive memory locations. Okay, the number of such kind of values that are stored in the consecutive memory locations is nothing but the word length. That what we have discussed in the word length. The number of values that are stored in the consecutive memory locations, it will be referred as word length. Word length. Okay. Here also, what he is trying to say is, it is impractical to assign distinct addresses to the individual bit locations in the memory. See, if the bunch of values are trying to store in a particular, if there are bunch of values which are always be grouped, that means they are not going to be separated. Every time they will be in a group. Okay, so it is practically impossible to separate them. Okay, so if I try to separate them also, it may not be possible. That means if, for example, if there are bunch of 6 values, if I try to give one value in a memory location called 100 and the other value in a memory location called 150 and the third one in a memory location called 170, like that, it is not a good thing. It is just like a family traveling in a reservation bogie. Okay, generally, for example, if a family consists of 20 members are traveling, okay, they have in a reservation bogie, they have reserved their tickets earlier. But if you observe, if whenever we try to reserve 20 tickets at a time, we cannot get all the 20 consecutive seats. That means 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We will not get any cost, whatever the time we may try, because at that time some X or Y or Z from somewhere is trying to book that particular seat. So obviously, though we try 20 consecutive seats, it may not be possible for us to get all the 20 consecutive seats. Okay, though we may get the seats in the same bogie, but we'll get some jumbled order seats. That means in between some seats will be reserved to somebody. So then what these 20 members are used to do, they will contact that some X or Y or Z who had booked the seats in between their consecutive numbers, and they will request them to take the other seats so that these guys can take the seats. That is the thing they used to do, isn't it, Anna? That is the concept here also. Okay, so there are memory addressables. There are three types. One is bit addressable, byte addressable, word addressable. Okay, so what he is trying to do here specify is, it is impractical to assign distinct addresses to individual bit locations in the memory. It is impractical to assign distinct addresses. That's what I have told. If the family of 25 members are there, so generally they don't prefer to sit on different places, because in between some 4 or 5 seats are reserved to some XYZ. They will request those XYZ to take their seats which are somewhere far away, so that all the 25 members, they used to be in a same place or a same surroundings. Like that here also, it is impractical to assign distant addresses to the individual bit locations in the memory. Okay, the most practical assignment to have successful bit locations in the memory. Okay, so it is nothing but word memory addressing. The most practical addressing means word addressing. Okay, see here, memory addressables are what is meant by byte addressable and what is meant by word addressable. Byte means it is a combination of 8 bits. Okay, so if 8 bits are stored consecutively, that means in a train, if 8 members are traveling, 8 same family members or same group of members are traveling, then it is called byte addressable. So that 8 persons need to be seated in a consecutive locations. Okay, if 16 members or 32 members are traveling in a train, 32 members are 32 what you call bunch of members, whether they group of members, okay, whatever the group may be, they all are going to some Sri Sailam or Tirupati, okay, or they may be going to Sabarimala. So there's some bunch of persons, some 32 members or 16 members like that. Okay, so the group of 16 members are 30. If the group consists of 8 members, then it will be referred as byte addressable. If the group consists of 16 or 32, then it is called word addressable. If the group has only one person, that means he is the one and only, then it will be referred as bit addressable. So bit addressable means only one person. That means there will be only one person who will be stored. There won't be any bunch of persons. Then it will be referred as bit addressable. If 8 persons are together, okay, that means we have to reserve the seats for 8 persons in a consecutive manner. That means one by one. Then it will be called as byte addressable. If we need to reserve a seat for 16 or 32 members, then it will be called as word. That means more than 8. It will be referred as word addressable. Okay, so that is about this concept. Next, memory operations. What are the various operations that are going to be performed by memory? So what he is trying to say is, see, what is meant by a program? Set of instructions. Okay, so what is an instruction consists of? The instruction consists of opcode and operands. Okay, where are the values of the operands are going to be stored? They are stored in the memory. Okay, that means, see, whatever the data means input values, intermediate values, output values. Okay, the values should be stored in the memory. Though they may store in the register is nothing but a memory unit. Okay, so whatever the instruction you are writing, that means whenever you write a program, what you used to do generally, used to save it now. Saving means it is going to be stored in a memory. Okay, That means whatever the program we are writing, whatever the input values we are giving, whatever the intermediate values we are getting, whatever the final output value we are getting, all these are storing in a memory. Okay, all these are storing in a memory. Next, to execute an instruction, the instruction that are stored in the memory has to be transferred to processor from memory location. See, everything is stored in the memory. Okay, if everything is stored in the memory, is it good? Does the signal, does a program executes? No, no. So for executing that particular program, what is the thing that is to be going to be happen, or what is the thing that should be happen is, first of all, the program or the values, not the program, the values that are stored in the memory, they should reach the processor. Then only the processor can perform some operation on that particular values, depending on the type of instruction. Okay, that means if two values comes from memory to processor, then if the instruction is addition, then the processor is going to perform some addition. If the instruction is subtraction, then the processor is going to perform some subtraction. If the instruction is multiplication, then the processor is going to perform some multiplication. That means the processor can perform some operation on the operands only when they come from the memory and reach the, only when they came from the memory and reach the processor. If not, the processor won't do anything. Next, whenever the processor performs some operation, we'll get some result. That means if I add two numbers, 12 and 13, I will get 25 as a result. I will get 25 as a result. Okay, that result should again store in the memory. The result also should store in the memory. That means whenever you are performing any operation, the operand should come from the memory. Though they may be registers, though they may be written in the memory locations, whatever it may be. Registers are also memory units. Okay, if you specify direct memory location, that is also a memory. Okay, except immediate value, rest all the things will come under the concept of memory. Okay, so whenever you are trying to perform, whenever the processor is trying to perform any operation on the operands, the operand should come from the memory. Then only the processor will perform the desired operation, either addition, subtraction, multiplication, or division. Okay, and whenever the operation is completed, whenever the operation is completed, we'll get some output. Okay, the value, the output value also should be moved from this, should be moved into the memory. So that is the memory operation. That means the obtained results must also be moved between the memory and the processor. Okay, the results what we are going to get, those will be moved from processor to memory. Okay, so that is the memory operations. Okay, for these things there are two. This is one more important thing one should remember, or one should learn. There are two important operations. One is the load operation and the other one is store operation. What is mean by loading and what is mean by storing? See, I think I have discussed previously, but once again I will give you a detailed introduction about this one. See, for example, I want to shift my house from Tenali to Guntur, or Guntur to Terali. Okay, so I have booked one lorry, transportation lorry. Okay, so then what that particular transportation lorry persons will do, they will just load the lorry with the goods that are present in my house. I might have a fridge, I might have a TV, I might have washing machine, something like that. Okay, so whenever I want to shift my house, okay, here the data, here I am performing shift operation from here Guntur to Tenali. Okay, so what I need to do, I need to call a transportation lorry. Okay, the persons will comes along with the lorry. What they used to do, they will load the lorry. That's what we will tell now. Load. They will load the lorry with my what we will call with my TV, with my washing machine, with my fridge, like that. So whatever the things I have, they used to load the lorry with my things. Okay. Then what they will do, after loading the lorry, they will transport that particular items to the destination. That means my house which I have newly constructed, or whatever it may be. Okay, or to my house which is already present in Tenali. Okay, so what they used to do, they used to load the vehicle with the load, with the what you call, with the items that are present in Tenali, and they used to travel. with that lorry up to where? Up to the desired destination, that is up to Tenali, to my house at Tenali. Okay, once they reached my house, what they used to do? Now they will take the items which are loaded previously. They will now take those particular fridge, particular TV, particular washing machine, whatever the things, and they used to place in my new home. They used to place in my new home. Okay, so that is called storing. Loading means taking something from the memory. See, house is a memory unit, isn't it or not? Because in house we will store. You may store money in the birva. You will store your items. You will store your laptops. You will store your books, whatever it may be. So home is nothing but a memory unit where you store everything. Okay. Loading means taking something from your home. That means taking something from your memory unit and placing it somewhere to the lorry. Lorries are nothing but registers. Lorries are nothing but registers. Okay. By using that register, we are transferring the data. Okay. And whenever and we will transfer the data from that register to where? The desired location, the desired another memory value. Okay, isn't it or not? So whenever you load the lorry, it will reach up to Tenali, my home at Tenali. Once it reached my home, what they are going to do? They use to again store the value. They used to again, what they used to do? They used to again store the value. So that is the thing that is going to happen. Loading and storing. Okay. So loading means taking something from the memory unit. Storing means taking something from the register and storing and placing it in a memory. Okay. If the data transfer is from memory to a register, then it is called load operation. Storing means register to memory, because where we will store? In memory. Okay, it may come from somewhere else, but it should be placed in the memory. So that is about the loading and store units. So that's what they have mentioned here. See, load, reading or fetching from the memory. Loading means we are taking something from the memory. Store means we are going to place it in the memory. Taking means technically it will be called as read operation. Okay, storing means technically it will be referred as write operation. So we are having read operation and write operation. Okay, reading means taking the value. Writing means storing the value. Okay, so that's what he has mentioned here. We are having load operation and store operation. The load instruction transfers a copy of content of a specific memory location to processor. See here carefully. See, a copy of contents of a specific memory or specific, 1 minute, I know it, spotlight, yeah. See here, if you observe, it will copy a contents of specific memory location to processor. That means the data it transferred is from memory location to processor. Then it is called load operation. Okay. So how can I perform the load operation? Means initially I will tell. That means, for example, if I want to shift my house, I will tell or I will call to the lorry transportation members about my house. Okay. So and so is my house, so and so is the address of my house. Then the persons will come along with the lorry. That's what that is going to happen. Initially the processor sends the address of the desired memory location to the memory and requests the contents to be read. So initially, if I want to change my house, I will call to some packers and movers company that so and so is my address. You just come to my address and take my items. Okay, that is the thing now. So I have to initiate the transaction. Then they will come. Okay, they will take all my items. The memory reads the data that is stored and the address and sends them to the processor. So that persons will come. They will load all the items into the lorry. So that's what will happen in the load operation. Next, store operation. Yeah, store. See, they have loaded all the lorry. Okay, and they want to send it to the processor. Okay, they have taken to the processor. Then the processor performs some operation. That means either it may perform some addition, subtraction, multiplication, or something. It has performed some operation. we have got some result. Okay, next, what is the thing that is to be done? The result should be stored in some memory location. Okay, that means here the data is being transferred from processor to a memory location. Such kind of operation is called stored operation. See, the store operations transfers an item of information from processor to the specific memory location. Here the data is going to be transferred from processor to the specific memory location. Okay, so from processor we are going to transfer the data to a memory location. Okay, na? If there is some value in that particular previously, for example, if I want to transfer the data that is present in my processor to a memory location by numbered 2000H. 2000H is the address of a memory location. Previously, if that memory location has a value of 45H or 50H, and now the new value is 75H, then what is the thing that is going to happen? Means that previous value is going to be deleted and the new value is going to be updated with the previous value. The new value is going to be updated with the previous value. Okay, that's what they are going to specify here. The process sends the address. Next, how come this will happen? Means here we does not initiate. The processor itself will initiate the address where we have to go. The processor itself will initiate the address where it should be placed. Okay, then obviously it will go to that particular address and it will store the value. Okay, so that is about store operation. Okay, so we'll stop here.